Hi and welcome to What Circuit. We've got quite an exciting one this time. Element 14, specifically Element 14 RoadTest, have actually given us an Agilent Arbitrary Waveform Generator review. So this is, it's a 33522B series, specifically it's the 33522B series, model, and that means it's dual channel, 30 MHz bandwidth and arbitrary waveform generator capable. So we're going to have a play with that, go through some of the functionality and give it a quick comparison. And the one you've probably seen us use in the lab before is a Rigel. It's a DG1022 and I have actually been using the single channel 30 MHz version at work for quite some time. That's the A series, so the previous version. So yeah, without much further ado, we'll have a play around, see what we can do with that, and let's kick off by unboxing it. So this is the box as it actually arrived in the post, and you may notice it's been opened already, and when this arrived it was basically like a kid at Christmas, so unboxing but slightly staged. Here we are. Right, so opening up the top of the box, we've got the usual Agilent, nice solid expanded polystyrene packaging here, and certificate of calibration. What do they calibrate on this? Right, so it doesn't actually give you any numbers at all, but does tell you it's been calibrated using 8.5 digit multimeter, universal counter and a spectrum analyzer. So presumably they've done the frequency there, done the actual output voltage of the spectrum analyzer. Interesting. Presumably for modulation. Right, put that aside. The power cord wasn't here, but we appear to have taken that out already. And we have two CDs with this. So we have the product reference CD-ROM, which has the operating series, got a service guide. So this is all standard downloadable off the Agilent website. Nothing that exciting. I wish they would give you a paper manual though. And Benchlink Waveform Builder Pro. But you need to buy a license if you want to use it longer than 30 days. But it does revert back to the basic functionality, which does have most of the stuff you need in there. Again, this is downloadable off the Agilent website, so I believe it's a nice bit of software, but we'll get it installed off here, give that a go. Right, generator itself. This is a nice bit of kit. The standard Agilent size box again. See, it's got these little bits on here. It's very rubberized all the way round, nice and rugged. The usual multi-position handle on it. Nice big screen on the front, which I'll finally take that off. USB interface, and I know that allows you to save and recall waveforms and import arbitrary waveforms, all of that. Nice clear user interface on it, 2 channels and a sync out there, and nice dedicated buttons for most of the functions. On the back we have a whole wealth of connectivity on here, so standard IC inlets. Now we actually have built in a standard, we've got the LAN on here, we've got USB, for some reason we have GPIB, my pity for you if you still have to use that in any kind of setup. Modulation in, what we've got, external trigger gate, FSK and burst input, got just output, 10 MHz output here and 10 MHz in. That's quite useful, especially if you have the OXCO option on this, so you're a nice accurate oscillator. You can actually then feed this out to other instruments, or take it in if you've got another one. Right, we'll get this powered up and have a play with that. Right, so first of all, let's just take you through the user interface roughly. And what we thought we could do is actually set up a dial tone. So dial tone multi-frequency, and in the US, quite a few other places, that's a combination of a 440 Hz wave and a 350 Hz sine wave. So let's generate 2 of those, bit of modulation, show you how it all goes. So we've got the function generator here. As you can see, we've got interesting sort of tab style display here, and that actually shows us channel 1 and in green channel 2, which corresponds to the two BNC connectors, which are also colour coded. So what you can basically do is start at the top here and work our way down, but as it's doing this for the first time, first of all let's set up our units. So we do want to work in frequency, and here we can either work in amplitude and offset or high and low. And particularly for myself, if I'm working with digital level signals, I'm doing something like pseudo-random binary, I really like being able to work in high and low voltages rather than that, so that's a nice option. And we've got amplitude as voltage peak to peak, sounds good to me. And start frequency as opposed to control and span, all sounds good. Right, it's waveforms. Let's have our first waveform. So just go onto the waveform button and select sine. And this automatically takes us through to the parameters menu. So first of all, parameters. Right, a couple of different ways of entering this. Let's start off with the keypad. So 440 Hertz. Nice and simple. Amplitude 2 volt peak to peak. Click at relays, all engages. So we just get back to this menu by going to the parameters button here, nice and easy. So let's do something a bit more interesting. Let's modulate that. So what type of modulation? Some modulation. Internal source, so you can either do the BNC connectors at the back or you can just generate it. And nice little feature on this, you choosing internal source of modulation doesn't then type your second channel. So if let's say you've got two channels both doing some kind of modulation, you've almost effectively got 4 channels working at once. Fantastic feature. So we've got sum, amplitude, shape, sine, and we want to sum that with a 350 Hertz sine wave. Brilliant. Modulation on. And you can see here it actually gives a little overview of what the output waveform is going to look like. So tell you what, let's hook that up, see what it sounds like. Right, waveform out to the scope here, and we've just got an old speaker around. Chuck that in the front there. And finally, channel 1, output on. So I really like this. Yeah, I'll just show you the modulation happening there. So I really like the way I've done the user interface here. It's very, very clear, and you've actually got the hard-coded buttons for basically everything you want to get to. So you want to do a sweep, you've got a dedicated sweep button. You want to do a burst, you've got a dedicated burst button. If you want to change your channel parameters, you go into here. And you can also do, output load. What do you want to set it to? 50 ohms, high Z. We set a high impedance load there. And that will automatically scale all the voltages that you select later on. And you've actually got a lot of options around all of these, and like I said, it's very easy to navigate. What I also like, let's say we want to change the parameters here, frequency. You're not just set by the keyform, not just doing it by the keypad there, but you can actually change it using the knob there as well. And a lot of times, you want to change your frequency on the fly, you want to change your amplitude on the fly, you've got all that control there. So the actual user interface of this, really nice to use. And the screen you've got here, it's very clear. Not sure how well it's going to show up on the video here. We tried it on the screen and it doesn't look so good, but it's very clear. Even from the angle I'm looking at here, it's very readable, very nice looking screen. You've got this above you on a shelf, something like that. No problem at all to use it. One of the ways I really find quite useful in here is actually the noise generation capability. And I find this is pretty common amongst most of the arbitrary waveform generators. But unlike some of the other ones, you've got a bit more flexibility, a bit more control with this one. Compared to something like the Rigel DG1022, which is the generator we used before now, you can actually control the bandwidth and noise, that sort of thing. So let's just give you a rough demonstration here. If we go, we're on noise. Right, so we've got some noise being generated here. Hopefully you can hear that. Looks like you can. So here we've got a bandwidth of 1 kHz. If we put it into the scope into fast Fourier transform mode, we can actually see the fast forwarder here. Nice continuous noise all the way across the band, up to a nice sort of 1 kHz. So let's go up to a 2 kHz bandwidth, and then 3 kHz bandwidth. And you see here, just getting more noise up to higher frequencies here. Okay, now that's one thing, but how can we actually use this? So let's say we generate a square waveform out. And let's disconnect the speaker for this part. There we are, so nice standard square waveform out. Now, let's put on some modulation. So we'll go back to summing modulation again, internal, and this time, instead of doing sine, we're going to do noise. Let's put some modulation on, and we can actually get noise added to this square wave here. Now we've got two controls. We can control the bandwidth of the noise. See up here we got up to 10, so let's take up to a much higher frequency there. So 100 kHz noise. We can also, so this is 100% modulation on this, we can actually dial this back. Now the great thing is, if you want to test out a signal, and you want to test out your system, and you want to see how well it functions with the presence of noise, you can generate a signal. You can add noise to it under very precisely controlled conditions, and you can see if your system still works. So I've shown you here with the square wave. You can also do this with something like pseudo-random binary numbers. So you can chuck out a whole stream of binary numbers, you can add noise to it, and see whether your system still works. In the same way here, let's say you're reading this in and you've got some hysteresis and comparator. You want to do a level detection. Again, you can do this, try out the system, and see how resistant it is. It's fantastic useful, this thing. Now one of the big claims that Agilent actually make for this generator is it can actually replace pulse generators, which is a pretty bold claim. So let's have a quick play around with the pulse functionality. So you get to pulse functionality the same way you get to any of the others. So go on to waveforms, pulse, and we're into our parameters menu here. So let's actually put that on. We've got a nice pulse at a period of 1 kHz here. And we've got an amplitude of 5.2 volts peak to peak, offset of 0. So let's, I don't want to read it on that. I want to read it as a high-low voltage. Back to parameters, high level. Let's do it as standard logic level, so plus 3.3 and 0 volts, there we are. So that's pretty nice and easy to work with. And right, so obviously you've got nice and easy. We can also do things like control the edge times. What can we actually go down to here on this? Edge time set to minimum of 9 nanoseconds apparently. I suspect though, let's take that frequency up a bit. And pulse width, may have to drop correspondingly on that. That's what we're getting on the scope there. There we are, nice that, and okay, we seem to be hitting an actual sort of minimum rising and falling time by 8.4 nanoseconds there. Right, so let's have a play around, a bit more interesting functionality. Let's bring in channel 2. Channel 2 on, and let's go to, we're already in pulse here, frequency, let's do 100 kHz again. And it's actually quite like on the UI. You notice if you set the parameters something where it can't automatically do it, it does actually try and work with you. Just try and bring it into something more sensible. And let's bring that right down. Right, so we've got 2 being generated here. Now this is nice. You can actually just control the phase. So we've currently got minus 180 degree phase shift between the two. and we can actually just move that right the way across all on digital control. Now, I didn't actually. You think you can actually do this on some of the lower end arbitrary waveform generators like the Rigel, but certainly compared to some of the analog units, you actually have to have a dedicated unit to do this kind of phase control. So it's nice, and you've got control over all the parameters you want for pulses, really. And also, if you combine this with something like the burst functionality, or what should we do? Let's do this on channel 1, shall we? Burst on for n number of cycles. How many cycles? There are 3 second burst. 3 second? 4 pulse burst. Okay, and that's basically most of the functionality you do have in a normal pulse generator. You've got control over falling and rising times. You've got things like bursts. I think you can even sweep some of the other parameters there, and it's a nice powerful unit, and you've got phase control between the 2 channels. Yeah, I like it. And you can even do all the standard functionality we saw before. If you want to do modulation, you want to add noise or anything to it, you can do all of that with the pulse functionality. So, yeah, I think that stands up really. It's not going to replace, your dedicated 32 channel pulse generator that you're going to use for testing, very big lumps of logic, but yeah, it's a good bit of kit. One other really nice feature with this, in fact, you set this to a sweep here as we're doing. So we're chucking out a sine wave, fixed amplitude, sweeping between 0 to, I think we're at about 20 megahertz at the moment. What we're doing, feeding it into oscilloscope through an example low pass filter here, and we've got the scope on FFT mode. So as you can see here, we actually start to build up a picture of each of these spikes, where each spike corresponds to a single frequency. As we start to build this up over time, you'll start to actually see a change in height with regards to frequency. So that's a change in amplitude, and you can actually start to build up a filter response using this technique. So the fact that this has got such a good, such an accurate response all the way over frequency compared to, as I say, the Rigel when it first came out, the DG1022. There's actually a big bug in it where the amplitude dropped as the frequency got all out towards 20 megahertz or so. This one doesn't suffer this problem, so you can actually plot out filter response using this. And we'll let this plot for you now. We'll just zoom through it because it takes quite a while. But just to show you some interesting things, you can actually do the sweep function here. So we talked before about being able to use the function generator to actually characterise the performance of circuits, and we're actually just going to give a quick practical example now. What we've got here is a bit of kit that we use to talk to microprocessors. So quite often, when you want to get a signal out for debugging or for test purposes, you send it out just as a raw serial signal, and normally this is going to be a 0 to 3.3 volt signal. Let's say you want to plug this into a PC or in some bit of industrial test equipment. You're going to want that out at standard RS-232 levels, which is about sort of plus minus 9 volts. So what we've got here, a bit of kit, you plug in a serial signal from microcontroller, it outputs signal that's at a proper RS-232 level. So a very basic bit of kit, and it just uses one level shifter IC. So what we can do with the function generator is to actually have a look and see if we can see what kind of speed this level shifter IC would go up to. So what we're currently doing, we've got a 9,600 bits per second signal we're putting in here. It's going between 0 and 3.3 volts. Edge time of 8.4 nanoseconds is not very important for this. And we're just feeding it in, and we've got it over on the scope here. Now the blue trace is the signal that's going into the level shifter, and the yellow trace is the signal that's coming out of the level shifter. So what we're going to do, we've also got the decoded data down here, but as soon as we move away from 9600 baud, that's going to be wrong anyway, so not that useful. Let's crank up the speed and let's see what happens. Okay, so we're at 100 kilobaud now. The data out still seems to pretty well match the data coming in. Right, hitting about a megabaud now, and you can start to see the edge, the rise and falls there, just getting a little bit of slew rate limitation on there. So instead of getting a nice sharp line, we're just getting a bit of an edge to it. And interesting, you can see a little bit of ringing actually on the blue trace there. Let's carry on going up. So let's go in fractions of a megabit here. So we're up to that 1.3, 1.5 megabaud there. It's getting worse. Up to about 2 megabaud. Let's zoom in again. 3. Oh, you can see we're actually starting to get runt signals here. Starting to look bad. 4, 5, and we're hitting 5 megabaud here, and you see that's looking pretty damn awful. So yeah, that gives us an idea of how the signal's actually performing. Right, so let's drop it back down to 9600 bits per second. And something else we talked about earlier, which is being able to use the modulation and adding a noise signal to it. So let's give that a go. So we're going to put on modulation here. We're going to do some modulation using an internal source, which is going to be noise. Let's put modulation on, and we're currently setting around 50%. So looking back on the oscilloscope screen, we can see now that the blue trace has gone noisy and the yellow trace is being unaffected. So that we know we've got 1 megahertz bandwidth noise on here. Obviously you can tune that to suit your system as you want. And we've got 50% amplitude noise on there. Let's whack up the amplitude of that piece by piece. Okay, it's got 6% noise, still looking a bit noisier on the blue trace, but still, level shifter's working perfectly. That's 65, coming up to 70% noise there. We're just about starting to get glitching coming in here at about 72% noise. Let's whack it right up. There we are, 97, 100%. So you start to see here the output IC is actually starting to mistake high from low at this point, and we're actually starting to get small bits of errors coming here. So in an actual system, this is going to come out as incorrectly read data. So that's, yeah, that works nicely. Just gives you an idea of the kind of thing you can use this for. Okay, so just going to run you through the Benchlink software that Agilent supply very quickly. So we won't make this a full run through, because to be honest, you can just download it for free and try it yourself. You don't even have to really do much registration at all. They ask you for an email address and a first and last name, but that's it. So just to give you a very quick overview, this is how you start off with a new waveform here. We've selected the series. We're going to do a dual sync waveform here. So we're going to output 2 different waveforms. So this is channel A and channel B. We've got a couple of different durations and running at 3 megasamples here, which is going to give us an overall number of samples, 999 kilosamples. That's going to fit within the 1 meg sample limit of the instrument that we have. It's got the 2 different samples here. Right, depending what you want to do, you can either put in your usual sort of functions up here, DC sine, half wave, triangle, ramp, all of that lot. Obviously you can actually build up waveforms, so you can add in, you can put on a particular waveform off this menu, then you can add on something else, and you can add them on one on top of each other, or you can put them in front, behind. If you want to have, say, some kind of burst waveform, you can do a sine for a few cycles, then put a DC waveform out for a bit, another sine waveform. One of the things I do like with sort of computer generated waveforms that you can't really do elsewhere, let's take freehand draw here on channel 1, and you can literally go up here. You can see the stepping here, that's due to the 16-bit resolution? No, we can do finer than that. That's just me going too quickly. We can also do line draw, where you just drag it out in terms of number of lines. And the usual point draw, where it uses interpolation to join between a couple of points here. Ooh, we've almost got a sync waveform out of there. And line draw by table. So let's say you've got, LT Spice, you're using a piecewise linear voltage source, where that's literally you draw points and it joins them up with straight lines. You can take your exactly same waveform source, put it into this table, and your waveform generator will dutifully output exactly the same waveform. So if you want to prove your waveform is behaving the same as LT Spice as it is in real life, it's a fantastic tool. One thing's equation editor here, I'll have to check, but I think this isn't available in the free one. We're running the 30-day free trial here. So here you've got the full mathematical library, you can build up all your mathematical functions. And yeah, it's a fully featured bit of software. It installs with absolutely no problem at all on Windows 7, Windows XP, all the usual suspects. And it's got the usual things where you can join it up to your actual instrument. We've tried this over USB, it does so with no problems whatsoever. That's the main bits really to it. Like I say, if you want a proper play, download it off the Agilent website and give it a go. So we've shown you the software that runs on the PC and showed you how you can create waveforms and that sort of thing. One of the things I really like about this is the fact that you can also just drop in a CSV file, which is comma separated file. And that you can create using basically any software you like, and you can write your own bit of software to do it, or you can just type it out in Notepad, absolutely anything you like. So let's just show you the import process. We've prepared one earlier. Let's see what happens. So we've got it on USB stick, plugged in the USB stick, waveforms, Arbitrary, Arbs, and we're going to import data, test waveform.csv. So literally just navigated to it on the USB stick here, select. Now we've got the source file data has multiple columns, so you can either do a single or an IQ arb. IQ uses both channels, so that's really nice. You can actually do, if you want to have two channels, you want to do differential outputs, something like that, you can do that all using CSV. We're going to do a single, we're going to do column 2, and it's going to be in ASCII format. Auto scaling, or you can do it manually. So scaling just says, what does the number correspond to in terms of voltage. So does 1 correspond to 1 volt, or does it correspond to 15 volts as the full scale output? Import data. Do you want to load the file? Yes, we do. There we are, having got sensible sample rate up, you can see that waveform has now completely appeared on the oscilloscope. And it may make it look difficult, but it's actually a very straightforward process there. So like I say, that's 5 minutes of editing data in Excel, save as a CSV, import it, done. So even if you don't want to use the Agilent software, this works really smoothly with basically anything you want to generate yourself. Also got the advantage, let's say you have an oscilloscope that isn't an Agilent one. If you've got the Hammock one like I've got here, you can easily save the voltage files as CSV files, muck around with it, throw it back into the Arbitrary waveform generator and play it back. So full compatibility with basically any manufacturer. Absolutely love that feature. So one of the nice things about this is it comes with a whole wealth of connectivity options, and one of the ones we really wanted to cover in the review was the LAN option. So what we've done, we've plugged this in with a LAN cable off to a network switch, and then we plugged the laptop here also into the network switch. So all we have to do now, if we go into the system menu, and we can literally just read the IP address straight off the screen there. All we have to do is type that IP address into a web browser if we go across the laptop. So the first screen we got here gives us a whole load of information about the network ports and all of that and what it's actually doing. And then the bit I really like, if we go into here and we slowly start up Java, and we get a full interactive front panel. So currently we're actually doing a sweep, so what we can go into here. Let's turn sweep off. Right, we actually have to apply that. So currently we have a sine at 20 megahertz. All of those. So let's put some modulation on there. AM modulation, internal at 80%. Now what we can do, we can hit apply in here, and one of the nice things, you can also fire up this command monitor here, and this tells you all the LXI commands that have gone out to make the changes that you've just told it to do. So, if you want to do an automated setup, you can go through, make all the changes that you want to do during a normal production run, then simply take this data, copy it, and use a program to send this data out one by one, line by line, and that's what you're going to get. So if you just cut over the scope, we'll show you. I won't bother with the actual. There's triggering here. There we are. So we put it successfully, just controlled the waveform generator over network. And of course here we're doing it with the two right next to each other. But if you want to, you can get a whole bank of these, control them all one thing running off another. If you had an oscilloscope that was also controlled via a LAN port, you could send a command, set the frequency here, you can read back the amplitude, send another command, read back the amplitude. All of this sort of control, customization, all becomes possible, and this web interface works really nicely. We've had a few before on some of the older bits of kit, sort of 5-6 years old, and they've just been quite buggy, but this one, absolutely rock solid. Yeah, it's a lovely way of doing it. So it feels like we covered a lot of stuff in this review, but to be honest, we've sort of done a bit more than scratch the surface of this maybe, but I wouldn't say much more than that. There's a whole load of functionality in this that we haven't actually covered, and this thing is absolutely incredible. One of the things that we've really enjoyed playing around with is something called the Waveform technology. And as far as I can make out, that basically ensures that if you've got high frequency artifacts in an otherwise much lower frequency signal, those artifacts are still shown very, very clearly. Agilent actually has a video up of this on YouTube as well, so have a look at that. Really interesting technology, one that puts it definitely above the competitors. And the stuff we've been doing this, we've taken this along to a hackathon for the weekend. We've had non-hardware engineers playing around with it. So that's been really interesting, just seeing actually how they get on with the user interface. And they've been finding it really, really easy to use. So we've had lots of opinions on this. And also in terms of robustness, and we've been doing some really horrible things with this. And we've built up a voltage multiplier circuit. We wanted to have a look at the effective frequency on it, so we hooked it straight up to this. We're getting about 300 odd volts out of there, and we've had this driving inductive loads with horrible kickback, that sort of thing. This thing hasn't blinked an eye, it's just gone through it, absolutely no problem at all. In terms of the modulation capabilities, and we've looked at mostly the sum modulation, but you've got the amplitude modulation, your FM, you've got your BPSK and FSK, you've got 16 QAM, all of that sort of stuff. And we're not RF guys, and we've barely scratched the surface of that. Some real amazing capabilities in there. So in this sort of thing, have a look through the manual as well. We've tried to cover the bits that we find useful, but the capabilities of this, absolutely amazing. Okay, so we've gone through a whole load of the functionality that's in this arbitrary waveform generator, but to be honest, we've actually probably missed out more stuff than we've covered here. So we've just taken you through a quick run of basically what excites us. And the amount of features in this thing is absolutely astonishing. It's an incredibly powerful function generator. One of the things we really like about it is the fact they've actually kept the user interface very simple while still getting all the features in there. And yeah, basically to sum up, on this thing, the performance is absolutely amazing. We haven't been able to break it, we haven't been able to find a situation where it isn't outputting the waveforms correctly. And especially as well, something like this, compared to some of the cheaper function generators, let's say like the Rigel, the DG1022, which is the one that we've been using at home most of the time, something like an arbitrary waveform generator is so dependent on the software that comes with it to actually generate the waveforms. And things like the Rigel software, it's not very good. And they've got issues with actually keeping it current with the latest versions of Windows. So basically you've got to keep your fingers crossed to hope that it will work on Windows 7. Windows 8 is just coming out now. Is it going to be updated, or are you going to be stuck keeping your PC around just to run that bit of software to keep your function generator working? In comparison, when you buy a bit of kit from Agilent, you know it's going to be updated, it's going to be kept current. And even the free piece of software is more than adequate for 90% of what you're doing. And there's always the 30-day free trial for the stuff. If you need the extra functionality, then you get it. So, and also things like Rigel and Handtech, they've got a track record of basically dropping support for older versions of the hardware compared to buying something like this. And if you're in the market for an arbitrary function generator, it's well worth looking at this if you're really going to make use of the functionality. And the base model for this is about £1,000 or so. So it's a definite step up from something like a Rigel or a Handtech or O1, that sort of thing. But it's worth having a look on. If you want to use a good bit of hardware, have a look at this. And also if you don't want to use Agilent software, something like this actually comes with the ability to be able to import CSV waveforms well, properly, all through the front panel. We haven't actually shown it, but it actually have a waveform editor that's built into this. As you're no surprise to anyone, I'm sure, it's not the greatest thing to use, but they've made the absolute best of what they've got. It's, compared to anything else I've seen before, it's very, very good, and you can build up complex waveforms slowly, but well. It's completely full-featured. One of the very bold claims they made about this is the fact that it's actually a pulse generator replacement, and actually having used it in quite a wide variety of scenarios, I think it actually lives up to that. Obviously, if you've got very high specifications or really unusual needs for high numbers of output channels at high speeds, that sort of thing, then yeah, you're still going to need a dedicated pulse generator. But for general lab use and for 99% of what you're using it for, this thing does it, and does it very, very well indeed. And that's very impressive indeed. We've also compared it to the A series of this, because the A series is what I've actually got at work. Can't be biased, but yeah, it stacks up. They've rounded off a lot of the rough edges, and it's a definite step up from the older versions. Yes, as I said, the price starts about £1,000. This one I think is close to about 2.5 or so, with 30 megahertz bandwidth, dual channel, and the arbitrary capability. One of the other things actually is a whole load of upgradable options on this, and this comes with 1 meg memory. You can actually go all the way up to 16 meg of memory, and that's one of the things we're very interested in. And something that comes up a lot for us, and something I use at work, is we use thermal batteries, where this actually uses an electrolyte that's made out of metal, and you melt it by having a very, very high temperature on there, powered by pyrotechnics. When that melts, that powers up a circuit because it functions as a battery. The problem is, every time you set off one of those thermal batteries, they're very, very much non-reusable, and it's several £100 down the drain. You don't want to do it all the time for doing circuit development. You have one of these, you run a thermal battery once, you capture the voltage output, you play it back on this repeatedly, you get your circuit development 99% of the way there, then you just finish it off by trying it with some real thermal batteries. That's going to pay for itself very quickly, and things like the 16 meg of memory allows you to do good 15-minute playback times, which is absolutely amazing. One of the other things I really should mention, Agilent are very heavily going down the upgrade later route, which is really interesting. We've already seen it a lot with their oscilloscopes, the 2000, 3000 series in particular, where you can upgrade bandwidth and add on things like arbitrary waveform capabilities after the sale. This sort of thing, they're doing a very similar idea. You can pick yourself either a 1 or 2 channel arbitrary waveform generator with 20 megahertz bandwidth without arbitrary capability. You can upgrade to 30 megahertz, or you can add on the arbitrary waveform capability. That's a really nice feature, particularly a lot of the hobbyist labs. You want to buy something, you find it's not quite enough, you add it on later without buying a whole other bit of kit. It's a really nice idea. Overall then, the verdict on this is an amazing bit of kit, and I would have no hesitation whatsoever in recommending it. Absolutely superb. I can think of almost nothing bad to say about it. Yeah, Agilent, absolutely love it, done a fantastic job. On behalf of What Circuit, I just want to say thanks again to Element 14 who have given us this to review, and it's great to be able to use this nice, this bit of kit here. If you like the review, please give us a thumbs up on YouTube, and thanks very much, and goodbye till next time. Thanks.